Hello, and welcome to episode 20 of TGI Kubernetes. And I'm Joe Beda. I'm your host. I'm the CTO of Heptio and one of the founders of Kubernetes. And in this, TGI Kubernetes is a weekly thing, weekly-ish, where I try to explore interesting new developments in Kubernetes or dig into a specific topic, a specific feature set of Kubernetes. I've done some live coding of certain features. So it's essentially me exploring parts of Kubernetes while everybody at home watches me screw things up live and try and get myself out of jams. So today we're going to be talking about Argo, which is a workflow system for Kubernetes. And we'll dig into what exactly that means when I say a workflow system. And do a little bit of compare and contrast with similar systems that are out there and talk about maybe some of the pros and cons against those different types of systems. But before I begin, can I do a little bit of a sound check? Can you all hear me fine? I think I'm a little bit too hot on the mic here. Let me go through it and do that. So yeah, if you can go ahead and let me know in the chat if you can hear me. And usually there's a little bit of a delay. All right, Diego in Vancouver. Awesome. Good to see you. All right, so I'm sounding good. All right. Over the sort of holiday break, I did on my own personal YouTube channel, I did a thing where I was talking more about the Glowforge and stuff like that. So I did a different setup in OBS. And I got 15 minutes into it before realizing that a lot of folks, like I wasn't broadcasting sound because I didn't do the sound check then. I'm like, I got it figured out. It's like, it turns out it's really easy to screw this stuff up. So yeah, well, welcome. Let's see, we got Suresh, Ed, Fernando, Mike, Kevin, Mary, Saeed, nice to see y'all. That's great. Great to see you. So I hope everybody had a good holiday season. I think we're getting back into the swing of things. Anton, Ale, good to see y'all. I was sick for most of the time. You can still hear it in my voice a little bit. I'm still recovering. I'm ready to get back to work. I'm tired of sitting at home sick, but still getting over it all. So I didn't quite get as much fun stuff in as I wanted to. But on the plus side, I didn't gain all that holiday weight because I wasn't feeling so well. So there's that to look forward to. Well, let's see. So with TGIK, I like to start out by digging into some of the sort of hot topics of what's happening around the Kubernetes world. Now, I haven't been monitoring things as closely as I probably want to be, and there hasn't been as much stuff going on over the last couple of weeks. But yeah, so you know what? The cold is just not Seattle. It's hitting everybody, and I think it actually might have been the flu. I got my flu shot and everything, but my wife's an MD, and she was saying that the flu shot this year was not as targeted as they like to see it. So it's always a little bit of a hit or miss type of thing. All right. So the one thing though that I think is on everybody's mind as of yesterday is Meltdown and Spectre, which are these new processor flaws that are part of the really every processor since 1985 to some degree. So this is really a fascinating and scary thing here. I haven't had the time myself to digest all the implications of this. I think there's still a lot of folks figuring this stuff out. I haven't had a chance to read the papers yet. And from watching smart folks I do know who've read them, they're like, yeah, I had to read them like several times to really understand what's going on. But the take home for me is what this shows us is that the idea of side channel attacks, and I'll define what those are in a second, have moved from something that's being theoretical to something that's actually real and we have to worry about and we have to mitigate and we have to protect ourselves against. And so that's a huge shift, and it's a whole new class of attacks that have gone from that theoretical realm to that sort of, weaponized or real, we have to worry about it type of thing. And I like I said, I still think that folks are figuring out what all that means. So first of all, a side channel attack is where you have two programs running next to each other on a piece of hardware, and without directly communicating between them, they impact that hardware to the point where you can actually glean information from one program to the other. And so a lot of times this comes down to timing, where you can do something, you can maybe drive a program to do something, and then you can do some other timing, and based on the timing, you can actually figure out what's going on. And so the information leakage doesn't end up being very fast. I saw somebody talk about like you could read memory across processes on the order of maybe 2K a second. But that's enough. If you read the right 2K of data, you can actually get really interesting and really scary stuff cross-process. What does this mean for sort of this cloud container infrastructure world? Well, I think it's important from and again, I'm not an expert here. I'm still really wrapping my head around all this stuff what this means. So the Meltdown attack can be mitigated with some kernel changes. And so running a new kernel, updating your OS does a lot to mitigate that stuff. Now, the crappy part is that mitigation slows things down dramatically, depending on how chatty your program is with the kernel. If you're making a lot of kernel calls, a lot of sys calls, then it can slow you down quite a bit. You hear everything from 15 to 30 to 50%. So that's a big deal. That's really, really bad. But a kernel change ends up mitigating this. And so the interesting thing here is that this makes an argument more for the serverless model, where you hire somebody and you make it be their job to worry about patching and rolling out and managing kernels. And this could be something as simple as, when we say serverless, I think we mean serverless in the grand scheme of things. It could be things like Lambda. It could be database as a service. You're really trusting that provider to deal with the patching. And you'll see this as people talk about what do you have to do to mitigate these things. You'll see things like App Engine or Lambda or what have you is already patched, already ready to deal with the Meltdown stuff. If you're running something like containers, what that means is that you have to go through and update your nodes to the new OS. You have to be able to manage patching and upgrading your kernels yourself across this stuff. Now, if you're running something like, say, GKE or a managed Kubernetes service, generally those things make it relatively easy to upgrade. So while it's not totally hands-off, if you actually sort of build your programs to work well with a Kubernetes system, and you actually have sort of all the playbooks in place for doing a Kubernetes upgrade, well, then doing an upgrade of the underlying kernel ends up being relatively easy and relatively straightforward. If you're doing a lot of stuff where you're hand rolling stuff, it may be that like upgrading the kernel is a really invasive thing, and that's something that you're going to have to think hard about. And so containers make it easier. They don't totally solve the problem, but they make it easier to deal with this. If you don't manage your nodes, if you don't manage your kernels yourself at all, then that would be with something like Amazon Fargate or ACI, then you're essentially in the same world as the rest of the serverless world. Now, the implications for Spectre are a little bit different. Because of the way that Spectre works, it's not clear whether it is mitigatable at all. And so what this means is that I think across all of these things, people are going to get a lot more paranoid about sharing hardware with other customers when it comes to really sensitive information. And so things that have been accepted to say, hey, it's okay, we can trust these barriers. Well, I think a lot of folks are going to start reevaluating those barriers. And in that case, that actually works against this more serverless world. Because I think if you really want to be super paranoid and you want to make sure that you're running on isolated hardware, then essentially moving to a platform that totally abstracts the hardware means that you don't get any guarantees around that. There's no way to go up to something like Lambda or App Engine and say, I want to make sure that my data never sits on a machine that runs workloads based from another customer. Those services are just not built, they're not structured, they're not priced to be able to provide that level of guarantee. In my mind, the nice thing about containers is that it actually can go either way. Right? You can use Kubernetes, you can use containers in a way where you make things automatically updated. But then if you are super paranoid about things, you can actually go through and use containers on dedicated hardware. You can run Kubernetes on hardware that you manage yourself. And it can be a mix and match type of thing, perhaps in the same cluster, perhaps across multiple clusters. The other interesting thing that I think is going to be an implication of this is I think that there's a little bit of a tension right now in the Kubernetes world between if you're running a big organization, you're providing platform services inside of that organization, do you run a couple of very large Kubernetes clusters, or do you run isolated clusters per tenant, per customer, per group that you're delivering services to. And I'm not quite sure what the implications are there yet, but I think that tenancy model, how hard and high the walls are between your different tenants, is going to be something that a lot of folks are going to be reevaluating, and we're going to start seeing that the sort of the cost and paranoia trade-offs are going to get a lot more nuanced than they were in the past. There was this assumption going on in the past where hey, if you run virtualization, that's a good boundary. You don't have to worry about things. I think that's kind of out the window. I think there's a level of paranoia that's going to come out of this. For me, this is a watershed moment. This is a bigger deal than something like Heartbleed, just because this is so fundamental to the way that we've been building processors for a long time, and it feels to me more akin to the NSA Snowden revelations of several years ago, in that it reset people's expectations in terms of the privacy of communications. And we're starting to see that play out now over time, where people are much more paranoid now about data sovereignty. They're much more paranoid about, what does safe harbor look like with respect to laws, and it's had a sweeping change in terms of the cloud landscape. And again, it's been years since we've seen the Snowden stuff, the first happen. It's been years, and we're still seeing that play out. And I think we're going to see this stuff play out over the next several years then also. So yeah, so it's interesting times. It's a little bit scary, but this is just the way that this stuff goes. And so I'm going to be looking forward to, I have to find some time to sit down and read the papers and really understand everything that's going on here. Before I move on to the next thing, any other sort of Kubernetes topics or comments, questions on this? Ralph's saying that there is some upside to containers, but this is all to the good that we're actually being more paranoid about this. Any other? Let's see. So Bacchus says, folks in our organization are speculating that Meltdown Inspector had been known to the certain three-letter agencies for a while. It's possible, man. I think, it's very easy to be paranoid about that stuff. I just don't know. On the one hand, there's a lot of capability. There's a lot of sort of, cloak and dagger stuff going on. On the other hand, they're humans also, right? We see this as sort of the NSA toolkits leak. We actually see the fact that, those organizations are not infallible either. I will say that both of these, my understanding is that both of these were independently discovered around multiple different avenues. Some of this is part of the Google Project Zero stuff. Jan here did that work. This stuff is fast. Google puts an amazing amount of resources in terms of security research. Some of that is just, really sort of a corporate value for Google around security. I think some of that is also in reaction to the Snowden NSA revelations from several years ago. I think it upped the level of paranoia within Google at least, and I think a lot of the fuzzing work, a lot of the targeted security research work that's been going on, that including this, I think was in reaction to that. So I'm not a security expert. I just play one on TV or YouTube. So take what I say with a grain of salt, but it's definitely interesting times moving forward here. All right, so let's move on and talk about Argo. So Argo is switching gears a little bit. Argo is a workflow engine for Kubernetes. And so what does workflow mean? There are certain things where you have long-running processes. You want to do certain things, and you want to be able to understand the sort of flow of these things over time, be able to visualize that, and understand when things fail, where and how they fail, capture logs along the way, perhaps be able to restart things and retry things at certain points along the workflow. A lot of the times you see this happen with CI and CD, right? So when you're doing continuous integration, you want to do a bunch of different steps. As you do those steps, you want to track where you are along that process, be able to record the results, that type of thing. but it actually has a lot of implications outside of CI and CD. I think the biggest place where I saw workflow when I was at Google for 10 years was when it came to MapReduce pipelines, where whenever you're doing data transformations, you'll have a set of steps. You'll want to run these things. You'll have a very good idea of inputs and outputs. And then along the way, you'll understand, where things are at, where they failed. You'll be able to sort of look at logs at certain points along it. And so when done right, workflow engines end up being a really flexible tool in your toolbox. In some ways, it's taking something like the Kubernetes job object and making it be multiple step type of thing. The interesting thing here, and I think if we look at the class of workflow stuff that's happening now, is that these things start integrating with Kubernetes itself. So each step along the way for your workflow ends up being a Kubernetes pod that runs. And so you actually get, each of the steps then ends up being something that runs natively in Kubernetes. So that, I think, is some really interesting stuff going on there. Like I said, you'll see it a lot in CI and CD type systems, but I think it has a lot of implications around other types of things. So you could imagine that, and again, this is part of maybe a CD type of thing, but you could imagine that as you're deploying your application, you want to, maybe you have to do a database migration. And so you have to take your application down, or maybe you have to put it into a read-only mode for a certain amount of time, do your database migration, flip some flags or something like that, do a restart, and then put it back into a read-write mode. As you're doing this migration, you want to orchestrate that, and you want to make sure that you keep track in a very sort of disciplined way of what you're going. So in some ways that's CD, in some ways it's application lifecycle. You could imagine all sorts of different places where this stuff comes into play. So Argo is one of the solutions in this space. I got a demo from the folks driving Argo. Applatix is the name of the company that's mainly behind it. I'm probably butchering their name. I apologize. This is Argo 2.0. It's based on CRDs, and so it's much more integrated with Kubernetes than the previous version. So I got a demo at KubeCon. Looks super interesting, and I think it's also interesting to compare and contrast this with some other workflow solutions that are in the Kubernetes space. And so I think the most interesting one, and I think it's different in a lot of ways, is Brigade. Now, I did an episode of TGIK on Brigade and got hung up on a bunch of stuff at the time. So Fernando says, would it be accurate to say that Argo is like Brigade, but instead of using JavaScript, it uses CRDs to design the workflows? I think that's accurate. I think that's definitely, and then Aaron says, using this on top of a fast to orchestrate functions will help with spaghetti fast. I think that's something also, because one of the things I want to point out here is fission workflows, which is essentially workflows built on a fast system too. So there's definitely a soup of ideas here around this. So Brigade, so I think the big difference is between Brigade and Argo is that Argo has a predetermined workflow. You essentially define the graph of all the steps of your workflow, and you render that out into a YAML file. But I think it uses a CRD under the covers that essentially shows you what is the sort of flow of your workflow over time. Whereas with Brigade, the workflow gets built up dynamically, and so what you can do. And there's other differences here, is you don't know the full spectrum of all the steps that you're going to take with a Brigade workflow to begin with. Instead, it can build the workflow incrementally as it executes. So in some ways, that's more dynamic, but in other ways, it I think works against some of the benefits that you can get by understanding what is the sort of scope of your workflow from the get-go. The other interesting thing is that Brigade appears, and I'm not the expert here, but I'm just, looking at some of the stuff that I've looked at so far. Brigade not only defines the workflow, but integrates with triggers for that workflow. And so with Argo, if let's say that you wanted to kick off a CI from a sort of GitHub submit. So you do a GitHub submit, GitHub then goes ahead and does a webhook into some place. and then that someplace then in turn kicks off a workflow. Well, there's nothing built into Argo that I've seen that will listen and turn that incoming webhook from GitHub into kicking off a workflow. Whereas Brigade does, you could build a connector to do that. I haven't seen anything built into Argo from the get-go. Whereas Brigade does go ahead and allows you to essentially define events and triggers that actually sit there. So there's this idea with Brigade where it's sitting there ambiently waiting for triggers, and then when those trigger happens, it happens. Whereas Argo is more, from what I've seen, like a fancy job object where it starts, it does a bunch of stuff, and then it ends, and you still need something to kick off that job object. Now, Mateus says, sounds like OpenShift's build config, image stream, deployment config workflow. It is. Now, one of the interesting things, I think there's definitely some commonality around this. Argo, from what I've seen, is more generic than, so Jesse says we have a separate project, Argo CI, for the GitHub event handling. So that's great to hear. I haven't seen that yet. But I think having this idea where you can separate out the triggers, then the things that you do on that trigger makes a ton of sense to me. And having those be conjoined like they are in Brigade feels like we may be conflating some things that don't need to be conflated. Okay, so a couple of things here. I just want to answer some of the comments here. So the OpenShift build config, image stream, deployment config workflow. I think one of the interesting things that I find with Argo is that it is factored so that it is a generic workflow system. I think Brigade wants to be a generic workflow system, but when I started looking at it, and maybe it's changed since I last took a deep look at this, what you end up doing is you end up defining this thing, and it's still ill-defined in the documentation here, with Brigade called a project. That project ends up being that thing that's listening, and it's tied to a Git repo in a very tight way. And so it's not clear how you use Brigade in a way that is separate from sort of a CI/CD type of thing. So that still seems like you can definitely see when you start looking under the covers with Brigade where it was built to be a CI/CD solution. And over time, I think folks have realized, hey, this is a more general thing, but you can still see the sort of lizard brain pieces of Brigade that are really grounded in CI and CD. So Aaron says Azure Fast has a durable orchestration functions on top of Azure Functions. Has these triggers too for orchestrating fast. Would love to see something like this in the Kate space. Yeah, and I think the other thing that's interesting here is AWS step functions. And this is essentially built on top of Lambda, similar type of thing. I haven't used step functions in Anger, so I don't know all the ins and outs, but it's a similar type of idea where you actually have a state machine that you define as you go through this stuff. Let's see. So the other thing I want to call out here is fission workflows. Fission workflows look really interesting too. It's essentially you can define a function as a workflow and that can call other things. And so this starts viewing the workflow as being sort of like a big function that actually calls into other stuff. Argo versus Shipyard, I don't know, honestly, Sudeep. I haven't played with them. There's definitely a lot of interesting stuff going on here. I haven't looked at Fission workflows in a deep way just because when I looked at Fission, it really floated on top of Kubernetes and it didn't integrate with Kubernetes in a deep way. And so for me, the min bar for anything playing in this area is I want to see it play well with Kubernetes namespaces. I want to see it play well with Kubernetes service accounts. I don't want it to run sort of as a root and define its own sort of like RBAC sort of authorization authentication model on top of Kubernetes, because I think that adds a whole nother layer on top of this. So I think if you look at something like Spinnaker is very much a heavy-duty sort of workflow system around deployment sitting on top of Kubernetes or AWS or whatever. I think this layer doesn't need to be as thick as all that. So there's that. There's step functions, which is really interesting also. Now, the one thing I did want to actually talk about is Matt Butcher, who did the Brigade work at Microsoft, just wrote this blog post, and I'll put all these links in the show notes, about why Brigade doesn't do YAML. And this is really, we need a native Kubernetes fast. I think Kubeless does a decent job of being pretty native dealing with Kubernetes. I know that the OpenFast folks are looking at integrating more deeply into Kubernetes also. So I think there's still work to be done there, but there's some exciting stuff happening. Um, so so Matt does in this blog post, he essentially creates, instead of calling about workflow as being like this thing he views it as kind of like a shell scripting language, but for a Kubernetes cluster. And, I think that's an interesting way to view this, but honestly, it doesn't resonate for me because, and he recognizes that there's some few realities is that containers are functionally different from Unix programs. And so because of that, the reason why I think shell scripting is so fascinating to people is they go through and you start by doing stuff on the command line, and then you're like, well, I keep executing these 3 commands again and again and again and again. Can I just batch those together? And so most shell scripts are developed incrementally based on turning something interactive into something that you want to capture. I don't think we see the same thing happen with Kubernetes. There is no sort of interactive run this job and then that job, then that job. And so that sort of like the shell script analogy for me really breaks down just because we don't have the command line for Kubernetes like we have the command line with your shell. So perhaps if we did have that, then it would make more sense to do that. And even if we did, even if we took Brigade and we ran it in an immediate mode type of thing, I still think that we would find that it would still feel overwrought because to run a single command, you have to essentially write a block of things to define what's going on. I think the most common thing here would be something like kube control run, or having a set of YAML files that you have in a directory and having a shell script that then iterates over those things, waiting for those things to end. And so those things start feeling, again, more declarative. I think the YAML that you're using to define the Kubernetes things makes sense because that then gets mirrored into, the way that you deal with Kubernetes is YAML, the way that you actually define the workflow is YAML also. And then he also talks about the event stuff here, which is great, but I don't think that the event stuff needs to be built into the workflow. I think the workflow is what you run, and then the way that you trigger it doesn't have to actually be built into the very same system. Now, philosophically, I think that there's different people who are going to approach this in different ways. I err on the side of the way what you run and the way that you run it. We tend to want to see those things be separate. And so I look at, like, say, Brendan's work around metaparticle. I think that stuff is super interesting, but I'm just not sure that I'm comfortable with having programs be self-managing to that degree. Building on the Unix analogies here, typically we have installers and then we have programs, or we have systemd unit files and then we have the things that the systemd unit files are running and managing. It would feel really weird to have something install its own systemd unit file, right? Or to have something run in a mode where it installs itself, but then it's also the program that runs. It feels like we're mixing those things together when we do things like have these event triggers defined by the program itself, or if we have the program deploy how it actually deploys itself onto a cluster. Again, I think that there's a philosophical sort of approach here, and I think definitely reasonable people can differ around this stuff. All right, so Donald says it could be a closer fit to the PowerShell model, though a structured resource coming out and passing on wouldn't all be that different. Yeah, I think the fact that PowerShell deals with structured things does actually fit here pretty well. Yeah, so that's a lot of interesting stuff going on here. I'm going to look at Argo specifically around this. The way that, let's go ahead and get the thing installed, and I haven't done anything yet, so I'm hitting this pretty cold, so hopefully we won't hit too many different issues here. So this thing is going to have me download a binary and put that into user local bin. Well, I'm not going to put it into user local bin, but let's go ahead and do a curl-o that. Oh, did that get it? No, I have to do -lo. There we go. L says do the redirects for curl. Ooh, this is slow. Yeah, PowerShell is open source and runs on Linux now. Yeah, I left All right, so here's me showing my age. When I left Microsoft, and that was 12, 14 years ago now, PowerShell was just getting started. And I remember a presentation they did. The code name for PowerShell was Monad, which obviously is a term of art now, but then seemed very, very strange. And I will admit that when they first started using the term Monad, I started giggling along with everybody else. I'm not always the most mature person. I'd like to think that over the past 14 years, I matured a little bit, but I never really used PowerShell in a deep way when I was in the Windows world. So like the idea of PowerShell, but then using it, I don't know. So like I don't have any strong opinions there. Okay, so we have this. We're gonna move Argo to Argo. All right, so that works. All right, so we got that thing downloaded. And then install the controller in UI. So this is really interesting here. Helm does this also, where it essentially knows how to install itself into the Kubernetes cluster. And this goes back to that philosophical thing. For me, this seems a little bit wacky to me. I'd love to actually see, at least with the instructions here, a way to run this in a dry run type of thing so that I can understand what exactly it's going to be installing into my cluster. But let's go through and see Argo install help. What does that get us? Oh, I have to do. So what I can do, is there a dry run here? Help, enable web console, controller name, controller image. So I don't see. I can set the kube config I use. I don't see a dry run here. No dry. So Jesse says, Jesse's one of the folks behind Argo. He says no dry run yet. So for me, this is a little bit scary because I'm like, what is this going to do with my cluster? I don't know, right? It's just going to like install some stuff. But it's going to install into kube system. So why don't we just sort of let her rip and we'll see what happens. Yeah. So first of all, I have a AWS cluster using the Kubernetes Quick Start. This stuff is still 1.8. We haven't updated this to 1.9 yet. I think we're in a little bit of a holding pattern to see how EKS shapes out before we put a ton of work into this. We're definitely going to do some work, but definitely know that a lot of folks are going to be switching to EKS as it becomes more available. So kube control get all namespace kube system. We can see what's going on there. We have a whole bunch of stuff running. So just Calico and kubedns, all the normal stuff running in there. Kube control get nodes. I have 2 nodes and a master going on here. So not a super powerful or big cluster going on here. So Jesse, can you answer for me? If I install this into a separate namespace, will it work? Or will I be sort of going off the beaten path and I may hit some issues there? Is it something that you all test a lot? Because all things being equal, I'd love to keep it a little bit separate from the rest of everything that's going on there. So, okay, so Jesse says that I can install. So let's go ahead and do that. And let's see what happens here. Okay, so if I do this namespace, config map. Yeah, and then, okay, then we can specify the server's account and other stuff. Multi-control. Okay, so it looks like, okay, so let's go ahead and do that. Will this create the namespace for us or will it be, okay. All right, so what do we have? So we create a CRD. We create a service account for Argo. We create a cluster role binding to cluster admin. Okay, so essentially this thing is running as admin, which is interesting. One of the things I did see though is that when you run workflows, you can actually say I want to run this workflow as this service account. Install namespace. Oh, it did. Okay, so Aaron says it got installed into Kube system. Is there an Argo uninstall? Okay, so that uninstalled it. So did I? Oh, nah. Okay, Argo. Was there an install namespace? It's different. Okay. Argo install namespace Argo. Go ahead and do that. All right, and so got install a kube system. Oh, Mateus, thanks. The option was supposed to be install namespace. Okay, Helm is coming soon. Implementation not 100% tested yet. Okay. Okay, we don't have the Argo namespace, so I can do kube control create namespace. Go ahead and do that. Okay, so now the thing is actually up and running. Okay, so we have that. We have a config map that gets for the workflow controller. We have a service account Argo, and then we run the controller, and then there's a UI, and then there's a service for the UI. You like the money bag for my for my prompt? Yeah, I tried to figure out sort of like what kind of emoji can I use here. Okay, so now this service here, so I see this, and this makes me a little bit interested. Kube control get and Argo get service Argo UI. All right, so this is a cluster IP one. Okay, so this is not exposed to the rest of the world, and that's good. I think these are one of those things that scare me a little bit. Is that, like, sometimes you'll see these systems have bad defaults where they'll open up something without a password to the world with, say, type equals load balancer here for something like this. But cluster IP is a reasonable place to be on this stuff. Okay, so now the question is, so here we are. We got it installed. Okay, and then we can go through and we can, well, let me go through and I'm going to clone this repo just so that we can actually really take a look at I like that you don't have to clone the repo to get up and running. That's a good thing. But we're going to clone it anyways. Move Argo to bin. Does that work? Yes, okay. And now I can clone it. All right. We'll go ahead and we'll take a look at this. All right, and let me close this window here. Okay, so here's a whole bunch of stuff. This is the Argo code, but we're going to look at examples, and there's a whole bunch of good examples here, which I like. And let's see. And so some of the examples that they point us at out the gate is the hello world example. So let's look at hello world example. All right. So this is obviously a CRD definition, and Argo IO v1 alpha 1 kind workflow. So this is using the generate name mechanisms in Kubernetes. Do folks know what this is? Generate name. This is interesting. I don't think there's been a lot of exposure around this. Most of the time when you create a resource in Kubernetes, so rewind a little bit. So one of the big differences between Google Compute Engine, which I designed the API for, and EC2, which was sort of definitely prior art that I was working with at the time, is that when you create, say, a VM in EC2, what you get back from EC2 is a random identifier that has no meaning. And at the time when I was doing GCE, the tagging stuff was still very, very new in AWS. And so it was up to you to actually keep track of, like, this random number, I-ABCDEFG. This random identifier maps to this VM that means this in my world. One of the things that we did with GCE out the gate is that we said every Compute Engine instance has to have a unique name. And then that name became the host ID, and we reflected that into DNS, and it became much easier to bring up systems that would refer to each other because things had a meaningful host name from the get-go. Well, this seemed like a good thing to me, but as we started talking to customers with the GCE API out the gate, there were a lot of folks who really assumed that, hey, when I bring up one of these things, I want to make sure that they get a unique name. Don't put it on me to create a unique name. And my answer to that was, just pick a random number. Chances are it's not going to conflict if you make it long enough. and then you're off to the races. But that was really sort of a big bar for people to actually get over, sort of like moving their scripts in the way that they thought about this stuff to to create a random number as part of their identifier was something that really confused folks. And so as we were designing the Kubernetes API, we really wanted to have the best of both worlds. And so everything in Kubernetes, every resource has a name. It has to have a name. But one of the things that you can do here is that if you don't want to think of a name, you can use this generate name metadata thing, which essentially says, hey, server, when you create this object, I want you to give it a name, and I want you to have that name sort of be prefixed with this thing. And so what this will do is it will cause this thing to generate a new resource. That resource will have a name that is prefixed with this, but then have a random identifier after it. So it says generate a unique name with this prefix by actually having, this works with pretty much any Kubernetes resource. And so you can use this with deployments and jobs and pods and whatever the heck else you want to do. So it's up to you whether you want to manage that uniqueness yourself or whether you want to let the system generate unique names for you. Let's see, and then we have a spec. In the spec, we have the entry point, and then we have a template. We see that the template obviously indexes into this, and this says run this container, call cowsay with hello world as the argument. So that seems pretty straightforward here. So one of the things that I like to see, and I don't think we do a good enough job across all of Kubernetes on this, is I'd really like to see some really easy to read definition of what does the schema for this type look like. The closest thing we have with Kubernetes is this stuff here. If you go to the API reference, like this stuff, have you guys all seen this page? Like, and I can look at sort of like, here's the pod thing, but then, you know, like, or that's just like, here's pod, right? We have this here, but then, you know, this is not super easy to read. And then it references things like pod spec. So you have to like link all over the place to be able to get to this stuff. Like, this is like, I know that like, you know, folks worked hard on this, but this is not a great experience. And so I think in the Kubernetes world, a lot of times people just copy and paste from examples and they try and figure out the schema based on looking at examples. We need, I think, to do a better job in general for that stuff. So I don't see that here. So autocomplete, I think, you know, so Aaron's saying autocomplete. Yeah, I think, you know, autocomplete helps, but again, like this goes back to my theory of different developers, you know, have different ways of working. Some people are what I call depth-first developers, where they really want to read the documentation, read a bunch of code, really understand what it is they're doing before they actually start operating with something. And then there's developers who are just like, I want to get some stuff done. If it seems like it works, then it works. I'm going to move on to the next thing. And that's really a breadth-first type of thing. They're really trying to be results-oriented. I think autocomplete definitely appeals towards those breadth-first people where they're just very task-oriented. I want to get stuff done. I'm more of a depth-first type of person. I really want to understand all the options and understand the theory behind stuff before I start operating. And because of that, autocomplete is there just in time, but I actually want it before I need it. I want to form an understanding before I need it. And so that's why I think autocomplete is definitely part of the solution here. But for me, it's not quite good enough. All right, well, let's run one of these things here. So I should be able to go through examples. I'll do Argo. I assume I have to do -n Argo because that's the Argo controller that we're talking to. Or no, this is the namespace because we're doing CRDs. So I shouldn't have to actually do anything there. Okay, so Argo, and this will go into the default namespace. And I say submit, and then hello world.yaml. All right, so here you can see it used the generate name. So I actually ended up with this thing here. It's pending. And then I can do Argo list. It's running. Can I do? We can do a get on this. Let's see what's happening. So it's running a pod. There's the pod name. Kube control get pods. Okay, so it's creating the container. So we're downloading the container for the first time here. So Javier says I can use wait here. I know, but I want to watch what's going on. I can use it there. So let's see what happens. All right, so it completed real fast there. Okay, so we can use wait when submitting. It actually waits for the whole thing. That's awesome. Okay, so that's really great. So that thing's up and run. It ran. Now if I do Argo list, I see this. I see it succeeded. I see the step that it ran. It has some information about when it created, things that happened. So this is actually a really nice sort of UI. So Argo operates through CRDs, and so you submit jobs by writing CRDs with that schema. It then watches for those things, generates and runs pods, and then I assume writes results back into the CRD. And so the Argo command line is a good way for dealing with those CRDs directly, but you can do it with kube control. I think what's going to be interesting is that as we break up kube control into smaller pieces and we do kube control extensions, it may make sense for Argo then, instead of shipping a completely separate command line utility, to extend kube control so that it feels like it's more part of the Kubernetes experience. But if I do kube control, describe workflow, what do we have here? So this describes the Argo workflow kind. And I do kube control get work. Can I see? Yeah, so there's the workflow. Here's the CRD that we get. And so here's the spec that we gave it. So this is essentially, and you can see that some stuff got expanded with some empty initializer-y type of things. And then let's see, and there's some labels that can be used that have some sort of high-level results for filtering. And then here's the status here. And so the status has all that information around the different steps, what happened when it started, the fact that it succeeded. All right, that's pretty cool. That's pretty cool. All right, so let's do a little bit more here. So let's look at the coinflip one. So what this does is we're saying we're going to do generate name again. Okay, so the coinflip example combines the use of a script result along with conditionals to take a dynamic path in the workflow. In this example, depending on the result of the first step, flip coin, the template will either run the head step or the tail step. And so let's see, so our entry point is coinflip. All right, so this gets a little bit interesting here, and I'll explain some of the syntax going on here. And the first step we're going to do is we're going to do this coin flip, and then we have a couple of other steps that are going to run, and they have this when predicate where we can essentially look at the results from the other thing to be able to see what happens. Okay, so coin flip goes through, it uses a Python 3.6 image, and then we can actually have the program running here. So this starts feeling a little bit serverless here because we actually have the program defined as part of the thing here. Import random, if results heads, result equals heads, and then just prints the result. So the result is coming out as an output. And then what we see here is that we have enough of programmability inside of here so that we actually have a little mini language for doing calculation and interpolation here. So I got to be honest, these little mini languages scare me a little bit, right? Because this is, how far down this rabbit hole do you go? And I think this definitely speaks to the argument that Matt made when talking about Brigade, whereas do we want to try and sort of reinvent a new language over time, or do we want to reuse something that we already know? And you can see that over time, this language could grow up and get more and more complicated. And I'll give you a sort of a parallel here. If you look at BigQuery, which is a data analytics project that's part of Google Cloud Platform, and And if you view the documentation here, it's a SQL-like thing. Let's see. And let's see if I can find, probably under concepts. So there's a bunch of functions that are, there's a little bit of a digression here. So it's SQL-like. And client libraries, so you actually end up, so it's fascinating because it starts out where you have a bunch of sort of like built-in functions in BigQuery. And over time, these functions get sort of bigger and bigger and bigger. And well, Fernando, I think Turing complete YAML, I think there's an interesting difference here, and I do want to get into this, is that there's the discussion of how do you actually generate the description of your workflow, and then there's the description of do you actually evaluate logic while you're executing that workflow. Now, Brigade actually brings these things together so that actually you use a Turing complete language for both describing your workflow, but then also making decisions as you execute your workflow. What happens with Argo is, I don't know if it's Turing complete, but your workflow itself has a mini language for making decisions, but the overall structure of that is something that is declarative on the outside. And you could use something like JSON, which is a Turing complete thing, to describe your structure, and then have that sort of be early bound logic versus late bound logic. And so this does start to get confusing, and I am sympathetic to the idea that like just pick one language and stick with it. But I think if you do that, you can get into this world where you feel like you're making the easy things hard, because even to get started, you have to actually grok this entire Turing complete world. But one of the things that you see here is that now you have SQL, but then inside your SQL, you actually you can use Lua to, I believe, no, you can use user-defined functions. I think you end up using JavaScript for this. Inside of Google, they picked Lua as the first thing. And so at some point, you actually end up with this little function thing for what you execute inside of these things for this sort of when step here. Another example here would be, I think, Terraform. Right, so Terraform has HCL. Inside of HCL, there's a mini language that's used to evaluate things, and I'm blanking on the name of that mini language right now, that ends up looking a little bit similar to this. Now, one of the interesting things here, and this does look in some way similar to perhaps Helm, because we actually have these sort of like double curly brace type of things, is that these curly braces don't let you change the structure of the thing. So these things are still just values that get evaluated. This is still going to be valid YAML. So one of the things you'll notice is that when you bring up a Helm chart in VS Code, you start seeing red squigglies everywhere, because that Helm chart is not real YAML, but it gets marked as YAML, and so it confuses the auto, and everything slows down because the YAML mode in VS Code is not smart about dealing with errors and slows down. Whereas with these workflows, because this thing is just inside of these values, this mini language here, this is still always going to be valid YAML. So Ed says multiple levels of language are useful for multiple purposes. Yeah, so there's no perfect answer here, right? There's no silver bullet. It really comes down to a philosophical way of viewing this stuff. All right, so this looks really interesting. So we're doing this. It's taking the output. It's actually running an evaluation here. And this runs, I assume, as part of the controller. And so you probably want to, so Helm is early-ish bound, right? It doesn't happen client-side, it happens server-side, but it actually ends up being a textual replacement using Go templating before the stuff gets submitted to Kubernetes. And it's not restricted to values of your YAML. It actually can impact the structure of the YAML. So that's sort of like, even though this may look like the templating in Helm, it's very different. All right, so let's go ahead and run this and see what happens. So let's see, submit, and this one was called coinflip.yaml. Okay, oh, I should have done the wait thing, but okay, Argo, get, that no? We'll do watch. All right. Oh man, watch. Does watch actually let you do color codes? Yeah, we'll do that. Oh, it doesn't work though. All right, pod initializing. So this thing is, I think we're just waiting for stuff to get downloaded here. So one of the interesting things that I think is really, really cool about, yeah, so we can do watch-d, Diego. I think the problem is that I like the fact that the Argo stuff has these little like dots here, but like for whatever reason, watch is not smart about showing those dots. And I am, do I have to have the, yeah, so something with like Unicode or something with failed to save artifacts. Oh, this is fascinating. Okay. All right, this is, all right, so it failed. And it said failed to save artifacts. And I like the icons here. Okay, so the service account that the container runs as needs to annotate the pod with the result. Okay, so here we're saving the artifacts back into the pod. Okay, so that's interesting. So what we can do is I'm gonna, so this is fascinating to me. So this is actually really interesting and really good. One of the good things that I like about Argo is the fact that it runs pods, and when it runs those pods, it runs them in the same context as the CRD that used to define that thing. And so that means that while the Argo controller has scope across the entire cluster, it's smart about making sure that it doesn't use that scope to expand things. So it actually runs pods in the scope of the user. So if you have access to write a CRD, that means you have a certain level of permissions inside of a cluster. Then you also have access to be able to run other stuff in that cluster. But I can't use Argo, for instance, to operate in a namespace that I don't have access to. Okay, so the failed to save artifacts message is misleading. So we have to enable this thing to be able to save as a pod annotation. Yeah, so Fernando, I did try watch with color. It didn't work. So I think it's a Unicode thing with watch, not the color thing. Okay, so to fix this, what we need to do is we either need to give the default service account in my default namespace permission to write to arbitrary pods, which currently the default service account and namespace can't do anything. Or I can create a new namespace for running Argo stuff. I can give that permission to do what I want, and then I can, when I run the workflow, I can say, hey, I want you to use this other service account. Let's do the second thing. So what I'm going to do is under kube control, create service account Argo. Okay, so now I have two kube control get service accounts. I have two service accounts now in my default namespace. I have one called Argo. Don't confuse this with the Argo namespace and the Argo service account in the Argo namespace. And then I have my default service account. Now I have to give the Argo service account access to do stuff. Now, I could give it access across my entire cluster. I probably don't want to do that. I'm going to give it root within my namespace. And so yeah, and Jesse says that Argo submit then supports the service account flag. We'll use that to be able to see how this stuff works. So using RBAC, we have default roles and role bindings, user-facing roles. So we have admin as a role binding. Okay, so we can do kube control, create, this is going to be role binding, and I always forget the syntax for this, but we want to do, we're going to call the role binding Argo, and we're going to do, instead we're going to do cluster role admin, and then instead of username, is there a service account? Service account equals default Argo. Okay. Okay, so now I have created the Argo service account, and then I've given it permission, essentially root, inside of this particular namespace. So this workflow won't be able to do stuff outside of the default namespace. It'll only be able to work within the namespace. And so now let's go through and we can do Argo submit coinflip.yaml. Let's do a help here. And I can do, when I do this, I can do service Argo coinflip.yaml. All right, so now get workflow. So now I bet you if we look at this, we're going to see, oh, look, it did a bunch of stuff. All right, we'll look at that because it's done. But one of the interesting things here is this actually changed the YAML that it submitted so that it actually said, go ahead and use this service account name. And then the Argo controller used that when executing those pods and actually used that to annotate the pod definition as things were going. One of the interesting things and this is, so it's interesting that Argo used this both to, I guess it was probably the sidecar that then was modifying its own pod definition to save the output. I bet you that was what was going on here. But anyway, so okay, so this is interesting. So now I can do Argo get, oh, what was the name of this thing again? Argo get. So we did the coin flip thing. This was and then it flipped the coin, and then it landed on heads, and then I assume, so yeah, so the sidecar annotates its own pod, so that actually means that we don't accidentally sort of use that rootness. I really like, that's actually a good thing because what it means is that we're reducing the amount of stuff that's happening inside the Argo controller, because the stuff that's happening inside the Argo controller has root. As much as possible, we want to have this happen in the context of the thing that's running. So that reduces that attack surface. And then we can do logs, okay. What happens if I do logs on this? Okay, pods. Oh, okay. So one of the interesting things here, Jesse, is that when I do logs on the entire workflow, it'd be great if it actually broke it up on a per step basis, and I can get all the logs for all the everythings. But it looks like I can go through, and I have to Argo logs. Okay, so Argo logs ends up just being essentially a kube control logs type of thing. And we saw heads, and that's the one that actually went ahead and executed there. So that shows a little bit of control flow going on there. All right, so I don't want to run down the clock too much. So one of the interesting things here, and I'm not gonna go ahead and install this right now, is sometimes the output from your step is going to be something bigger than what can be stored in an annotation or can be actually written by Kubernetes. One of the lessons when you talk to folks who worked on OpenShift, and I think earlier somebody brought up the whole OpenShift workflow building type of thing, is that OpenShift really hit the Kubernetes database, the etcd behind Kubernetes, super hard to be able to actually save the results of every step of a workflow. I think we're still going to see that a little bit if you're running a ton of builds here. But at the end of the day, where and how do you store artifacts, whether those be things that you build or whether they be logs that are really large, how and where you store those artifacts is something that we need to think hard about. And you don't want to store all that stuff into Kubernetes. And so having an object store that you can talk to makes a ton of sense. I'd be interested to know sort of what types of things Argo can talk to as an object store for storing this data. Here, there's this assumption that you can go ahead and use Minio. I think, so Minio, for those who aren't familiar, is essentially an S3 workalike. It's super flexible, though. It's a really interesting project. You can use it to actually be backed by, okay, so Jesse says S3 and Artifactory, which is the JFrog thing. You can use Minio can be backed by like a single disk, and so you can use it as sort of a local S3. It can operate in a translation mode where it can provide higher fidelity S3 compatibility when talking to something like Google Cloud Storage or maybe Azure Blob Storage or what have you. So it can essentially be a blob store or an object store translation layer. One of the interesting things here is that you have to go through and configure Argo to be able to know which store and what are the authentication that you need to use there. Couple of things here when you look at what's on screen here. The first thing is that Minio, when installed by default, has a hard-coded access key and secret. That's horrifying. That's a bad idea. I think somebody should take a hard look at the Minio Helm chart and maybe actually think about, hey, can we force people to pick a unique secret to begin with there? The next thing is that, so inside of Google, every Borg cluster is paired with a Colossus cluster. And so this means that you assume when you're running stuff on Borg that you actually have something that feels like a fancy S3 that you can talk to and that you can store data into. Not only that, but that thing is well integrated with the authentication and authorization systems that works with the rest of Kubernetes. And this is really a missing piece in Borg, right? In the Borg sort of, in the Google world. And we don't have anything similar in Kubernetes. And the fact that you have to sort of like as more and more things want to be able to talk to an object store, and we see this with Arc here at Heptio, right? Because we want to do a backup, we want to store that backup someplace, or we want to run some stuff and you want to be able to store some big data someplace. Big data. We're going to find that this step of saying, hey, configure your object store for this particular service, we're going to see that happen more and more and more and more. There's a similar step when you're defining Arc, right? When you're actually installing and managing Arc here. And so, one idea here is, could we go through and have a standard way to say, hey, here's the way, for this particular cluster, I want you to use this endpoint, this system, and this credential system to be able to actually write stuff. Could we actually start having a way of talking about here's the object store that I want you to use that gets paired with this cluster? Aaron here says like Ceph via Rook, I think is interesting. S3 is interesting. I think there's a couple of problems. Is number one, how do you point to where this thing is? How do we actually identify what the common API here is? Because if you have to talk 12 different APIs to do this, that's going to make it that much harder. For good or ill, the S3 API is good enough. And with things like Minio acting as a translation layer, I think it becomes that much more doable. And then the third thing here is, how do you authenticate to this thing? And this really starts to beg the question of workload to workload authentication. It's something that we don't have a good answer to in the Kubernetes world. And the workload identity working group is actively working on this. But I think if we can bring all these things together, then you'll be able to skip this step, and there'll be a default blob store, a default object store that you can write stuff to that gets installed and paired with a Kubernetes cluster. Dare to dream. Maybe we'll get there someday. It's something I'd like to see happen. It would definitely make stuff like this a lot easier. I'm not going to go through and install install Minio right now. I don't think we have time to do that. The one thing I did want to do, though, is look at the UI for Argo. So to do that, so the easiest thing to do here is let's just do port forward. I want to write a utility to help with this, but I have to find some time. I was going to do it, but last week, but I was sick, right? It was my grand plan. I was going to hack out this utility to help with port forwarding. But let's do this the hard way. So what we're going to do, get pods, right? We get this. We have this Argo UI thing here. Kube control. We're looking for port 80 on that thing. And so we can do kube control port forward. Or is it port forward? And we're going to go to that pod. And we're going to do 8080 to 80. And then now, if I go to localhost, does this magically work? Empty response, what's going on? Connection refused. So Aaron says, yeah, we really need port forwarding for things other than pods. Totally agree. What did I screw up here? That should have worked, but I must have messed something up here. Does it, Jesse, does it listen on port 80? Am I doing the right thing here? Oh, target port is 8001. Okay. There we go. All right, so here's the Argo UI. All right, so this is actually really, really cool. So this is great because we can start looking at this. You can see the workflow. We can see what happened. We can look at the YAML for this particular thing. We can look at the logs and then the artifacts that might have gotten written someplace. So I actually think this is really cool. And so you can see that this is skipped. All right, so I really like the UI here. This is great. One of the interesting things here, and Jesse, I think this is something that the Kubernetes UI faces, it's something that Helm faces, is that this may be a place where you're using the root superpowers that you have to be able to read into namespaces that you might not otherwise want to read. And so you could imagine that one of the outputs, if you start looking at the logs here, it's very easy when you have logs, when you're doing a CI/CD system, to accidentally start dumping secrets. Now, anybody who has access to this UI can go ahead and read those secrets. And so that's not a great solution there. We don't have a great solution across all of Kubernetes to be able to do this. One of the things that might be interesting here is to be able to separate out the installation of the UI from the Argo controller, and then let people install a UI on a namespace by namespace basis. And so I can have my own personal UI that has maybe some sort of symmetric token for being able to get to it, or a password. So I can have like a UI for a particular namespace and then lock that down. Still not great. There's no great solution here right now for this. I'll be honest about this. But it's something that you should definitely be aware of, is that this probably is a security issue that you're going to want to think about. Now, it looks like there's no way to actually go through and create new workflows from this UI, which is a good thing. This is read-only, so that you're not essentially, otherwise it'd be a huge gaping security hole. Now we're just talking information leakage versus being able to do arbitrary code execution type of things. Okay, so one of the things I want to do before we go through, and let me turn this in the background, before we go through and I sign off, is I do want to look at a more complicated workflow. So So I just clicked on one at random, and I'm looking at this one called Fun with GIFs. Enable example of GIF processing image magic and GIFsicle. This is an example of a workflow processing GIFs using image magic and GIFsicle. The workflow creates a PVC that is used for locally storing the download images and then running convert and GIFsicle on the images. The output gets written in the PV itself in the output directory. This directory is then considered as an artifact and uploaded to the cloud. Okay, so that's fascinating. We don't have the artifact stuff set up, but this is like, I love this pattern of bundling this stuff after the fact. That's really cool. The fact that you're using this volume mount and the common volume across all these things is really interesting also. You may hit the issue that like it's easy to have. Okay, so this is interesting here. Okay, so first of all, for folks who are reading at home, one of the sort of interesting parts about the Argo workflow steps is you see this double dash thing here. And I'm honestly not a huge fan of this, but essentially this is a list within a list. Like if we were going to actually go ahead and like, you could rewrite this, you know, as like, you know, so like if we go through it, like actually let's go through it and we're going to take this and then we're going to do YAML to JSON. No, we want the other way around. All right, but we can do this. So you can see that each of these steps is an array within an array. That's what that double dash actually turns itself into. And so what happens is that the first level array are things that are going to happen sequentially, and then everything inside of that are things that are going to be happening in parallel. And so the step 5a, the combined horizontal and combined vertical, those things will be happening in parallel, you know, at the same time concurrently. The interesting thing, though, is that if you come down here, both of these things are using the work dir. So I don't know how that works because PVCs generally can only be attached to one at a time. So these things probably do end up executing sequentially, but it's just you're using Kubernetes to make them happen sequentially versus not. I think this pattern of using sort of a local, like a PVC to do this stuff is going to be much, much more interesting as we get more local volume support. Because then you can actually, all this stuff will run on one node, and then you can bundle it up and put it in the cloud eventually. Yeah. So Jesse says DAG, dependency-based definition of workflow, is coming next as an alternative to steps. Yeah, for me, I think it would be just better if there was just some explicit sort of like this stuff happens in parallel versus this stuff happens in serial, right? Just because the double dash stuff just to me feels a little bit too cute. I'll say Fernand says. No, it's not like it's interesting. It's just like I said, it's a little bit too cute for me, right? I think it's not obvious to people what's going on here, and I think there's a certain amount of explicitness that I think might make this stuff a little bit easier to deal with. Okay, so Ferdinand says, what are your thoughts about using Vault as a secret store for Kubernetes cluster? Would it make it easier for the de facto secret store for Kubernetes? Okay, so secrets in Kubernetes and Vault is a very deep topic. The big question is, okay, let's say that you have Vault, and running Vault in production is not an easy thing to begin with, just because Vault has some very opinionated ideas around sealing, unsealing, and like it's easy to get yourself wedged with that. But the big question is, how do you authenticate to Vault? And there's two ways that you can think about it. You can use Vault as a provider for actually storing Kubernetes secrets and then have integration with the Kubernetes API server. There's work coming in 1.10 and beyond to essentially have extensible secret encryption mechanisms where you can use KMS or you can use Vault or whatever, and you'll have the API server talking to those things directly. Or you can make a Vault available to your workloads, and then you have your workloads talk to Vault directly to actually get secrets. And you can do that with initializers, you can do that with sidecars or whatever. But now as the question comes, how do you actually how do you authenticate to Vault? And there is stuff built into Vault for authentication. If I can spell right. They mark this as production ready. I would give this an alpha type of thing. They're doing some really weird stuff here. I've given them this feedback. I've given them verbiage that I wish they would put on this page. But I am not a huge fan of the way that Vault is doing this integration. Now, to be clear, there aren't a lot of great ways to do it, but I think this is a wonky way to do it, even given the constraints that we have with Kubernetes. And so what happens here is you talk to Vault, and then you take your service account token that you're using in Kubernetes, and you give that to Vault. So now you essentially are giving Vault the keys to the kingdom. Now, you're going to trust Vault because it's a trusted component. But in general, we don't want to train users to give that JOT, that service account JOT, to anything beyond the Kubernetes API server. It's really bad to actually give that to anybody else because they can then start acting as you when they're actually talking to it. So if you give that to some other service, you better trust that that service is going to act with it responsibly. Vault's probably okay, but just in general, it's a bad smell to give that service account token to anybody else. And then instead of having Vault use its own service account to talk to Kubernetes, it then goes ahead and, let's see, I believe, maybe they fixed this. But it then talks to this token review API, which really wasn't supposed to be used by anything beyond the kubelet. It talks to this thing using, okay, so it is using a separate service account name now. So, okay, that's not awful, but it's just not great. So I'm just like, this whole thing is just a really kind of like mediocre pattern. It's not horrible, but I'm not super excited about it. And at the end of the day, you know, your security is only as good as the secrets that you're storing in Kubernetes. And as secure as Kubernetes is around moving secrets around, and I think we can do better than the way that Kubernetes deals with secrets right now. It's a much longer discussion. I think it's why I went off and started this other project called Spiffy, which is trying to solve this at a sort of more fundamental level. But we're still, like, this is still early days for Spiffy. And so it's kind of one of those things of we're still early on. So Istio also uses Kubernetes secrets to essentially move around TLS certificates, which means that Istio is only secure as Kubernetes secrets are secure. Istio is using Spiffy in terms of the schemas for actually encoding names into those certificates. But Spiffy is along with this open implementation called Spire, is working to provide a completely separate identity control plane, which can be secured at a different level and actually be more secure and sort of have semi-trust between Spire and Kubernetes. And I think that's really probably the best way forward for everybody, but it's going to take us time to go ahead and get there. All right, so I do want to run, before we stop, I do want to run something that's going to be more interesting that we can watch happen. So yeah, TGIK session on Kubernetes security and best practices and roadmap would be great. Yeah, it's such a deep topic. I have to think hard about sort of like, you know, what can I say? Like, I know where we want to go. I know where we're at. I'm like, we're not where we want to be yet there. I think we're still early days on that stuff. Okay, so Jesse, if I was going to look for something that doesn't use the artifact repository, that does something a little bit more interesting, I want to see, is there anything, the coinflip recursive or loops? Let's do the coinflip recursive because that's kind of interesting. Okay, so this thing here, what this does is that it goes through and it runs, and if we get tails, it runs coinflip again, so it'll actually keep running until it gets heads. No, Fernand, I'm like really passionate about this stuff. I just like, man, it's a deep topic. So let's do the coinflip recursive one and see what we end up with. Go, let's see, Argo submit, right? Coin recursive. And then, oh, look, it auto updates. So it's doing like a, oh, what happened? Oh, you know what? It wasn't able to actually write the artifact because I didn't give it the service account. Okay. And then we need to, oh, no dash. Okay. This thing is doing its thing. We can see it succeeded. Oh man, it hit heads the first time. All right, let's hit it again. All right, so there we go. So this is interesting because there are dynamic things that are happening here, and then we got to succeeded. So, and the way that it is that this looks like a sub workflow that ends up getting run, and you don't define that sub workflow until the thing actually runs. So that's actually kind of interesting. Yeah, it looks like, though, to really do some interesting, I love the idea that like it does pair with some sort of artifact repository so that you can actually push and pull stuff. I like the idea of being able to use with PVCs, with persistent volumes. So you can do something like do a git checkout when you start and then go ahead and operate on that. I'm wondering if you can reuse a persistent volume between runs and serialize on that, so that perhaps you can, or at least have a pool of these things so that if if the git checkout ends up taking a long time, this is some of the things that people do with Jenkins to be able to really speed things up. So Jesse says, yeah, you can reuse existing volumes. So a lot of interesting stuff going on there. All right, so that, I think I'm with that. I'm pretty much at my time here. I think Argo looks super cool to me. I think one of the interesting things that I would love to do is explore, what does it look like? And again, I'm not sure if it's a good idea or not. So again, it's one of these things that I'd like to explore is as we look at something that's more complicated, like the CI definition for InfluxDB, is there a way that we can use something like JSONit to be able to output this YAML and create something that is itself templated? And if you do that, do you end up creating confusion because you have both templating at runtime versus templating at creation time? Yeah, I'm not sure if it's a good idea or not. It's definitely interesting though. So definitely some interesting stuff going on there. So just says Kubeflow uses KSON to generate their Argo workflows. Yes, so I know that Kubeflow was using it. I didn't realize that Kubeflow was also using Argo. So that's definitely interesting also. And I love the idea that Argo makes sense with things like Kubeflow. So for those not in the know, so Kubeflow is essentially a machine learning toolkit, and workflow engines and machine learning, again, it's very much like big data where you want to do a bunch of steps. You want to be able to save stuff away. You want to actually sort of like run stuff to completion. It's a really good fit. It's not strictly CI/CD, but it reuses a lot of the same concepts that you'd see behind a workflow that you would use workflow for. Donald says, would also be cool if, as part of Argo CI, artifacts hooks could use custom ideas of versioning and external semantics like Concourse's idea of resource types. I'm not super familiar with Concourse. I do know that Argo does have, as part of the schema, and this is one of the reasons why it may be interesting to have the schema spelled out in a documentation page, but as that you can have variables that become inputs into the workflow itself when you execute the workflow. I'm not quite sure. Like when I do a submit, there's parameters that actually can be pushed in there too. And then version of data with ML, since data is code, exactly. You want to track provenance and stuff like that. Super interesting stuff going on there. All right, with that, I'm going to call it a day. Any last questions, folks, before I go ahead and sign off? Again, I'm not the expert here, but I really like a lot of what I see with Argo. Super interesting stuff. I love the fact that it uses CRDs in a native way, that it works with the execution model of Kubernetes with pods and service accounts instead of working against it. So very, very cool stuff. Thank you, Jesse, and for all your work on Argo. It's great to see stuff like this out there in the wild. And if you haven't already, hit the subscribe button. Otherwise, I'll see you all next week, and hopefully I won't sound quite as sick. Hopefully I'll be on the mend by then. So, all right. I'll talk to you all later.